Hey guys, it's Dr. Conklin. I'm here to do a video with you today. Welcome back from our Thanksgiving break. We hope you had a great day and time with your family and we're safe. If you could take out your Unit 3 functions packet, and we're going to turn to page 9 for today. Okay, so we're going to talk about page 9 in a second, and I know we've already defined for you guys a little bit what a function is. In one of our videos, we talked about the idea that a function, again, we're on page 9, is when no x value repeats. Okay, so that's the main idea of a function, but I want to talk a little bit more about what is a function. So if I look, I'm just going to do an example, so just sort of follow along with me. My birthday is on June 18th. So Dr. Conklin's birthday is on June 18th. One of my good friends, whose name happens to be Beyonce, is also in June, on June 19th. Okay? So right here we have sort of what's called a function, because if we look at our input here, our input is the name of the person, and our output is the date of their birth. Now, let's say we have somebody else in our class, Ryan. And his birthday is also June 19th. That is definitely a possible situation. So we could have a different name here, but the same birthday. Now, what if I also told you that Brian's birthday was April 3rd? Well, what's up with that? Are you allowed to have a birthday on two different dates? You cannot do that. You can't have one person whose birthday lands on two different dates. That's not possible. And that's sort of the idea of a function. If we have two arrows, so two x values, or I'm sorry, not two, one, hello. We have one x value. It has to go to one y value. Now, it's okay to have an x value go to the same y value, but we can't have the situation with Brian here, where Brian has two birth dates. It's okay for Beyonce and Brian to share the same birthday, okay? But we can't have them, one person, having the same birthday on two different days. So that's sort of the idea of a function. So let's look at a few relations here. And the directions say to compare the two relations. So we have our first relation, 0, 1, 1, 2, 2, 4. And I'm going to look to see if this is a function. 0, 1, 2. So if I look here, do any of the x values repeat? They don't. So this is, yes, a function. Okay. Now let's look at our second relation. Again, I'm going to focus on my x values, 0, 1, 1. Here I see that we have 1 repeating. So that means, right, that this is not a function because the x values do repeat. Okay, so now we're going to also look at something called the vertical line test. So the vertical line test, or the VLT, some of you might remember this, is when we look to see if a vertical line crosses a function more than once. So we're going to look at each of these graphs independently. If I go through A and I scroll over, do you guys see how this is only hitting at one spot? Like if right here it's only hitting at one spot, right? If I move it along here, it's still only ever hitting at one spot. So if a function hits at one spot only, it is passing the vertical line test. Okay? If I look at B, so let me draw my vertical line. Same thing, this is a linear function. Excuse me. If I move my line back and forth, I can see it's only going to hit at one spot every place that it's crossing. Now, let's see, guys. So again, yes, passes the VLT. Let's look over here. This is where it gets a little trickier. I'm going to draw my vertical line for my circle. Oh wait, sorry, we're doing C first. So I'm over here. So if I draw my vertical line and I start going through, do you guys see how at this spot right here, if I can find even one spot where it's hitting twice, it is not going to be, because it's going to fail the vertical line test. Okay? Same thing here for our circle. I'm drawing a vertical line. I'm going to swoop and look through. And if I look here, it's passing once, passing twice. So again, this is going to fail the VLT. Okay, so we know some of the numbers that you guys may have in your packet that it didn't copy like absolutely perfectly. Okay, so I'm going to have you flip to page 9. Oh wait, this is page 10. Hello. Page 10. And I just want to talk a little bit about domain and range. So the domain and the range, the domain we talked about is all the x values, and the range is all the y values. And one trick for that, guys, is that if you have the point x comma y, the x comes first in the alphabet, just like the word domain does, whereas y, like the word range does, comes second. You can sort of remember those in alphabetical order. So the domain and the range, so there's a couple things we want to remember. The domain is when you look along the y-axis to see if there's any numbers that we have to stop at. So you notice here, guys, if I follow through how the arrows are going on forever in both directions for the y's, that means for our domain, the answer is every possible thing we could think of, which is this fancy R, which means all real numbers. Okay? Now for the range, this is a little bit different. If we look this way, right, I'm going to circle this. If I look here, do you guys see how I'm going to go down, down, down? All these could be answers because they have arrows, but what happens when I get to here? If I look here, this stops. Oops, well, my line should stop. I can't go anywhere below 0. So for the range, we would start at 0 and go on forever to infinity. Okay, so a few more examples here. If I have a line, any line, and actually C and B are both lines, those domain and range answers are always going to be all real numbers. Because if we look, we can see, let me draw my straight line. Oh, it's not dark enough. And I move this up and down. Sorry guys, I'm struggling here with my line. If I look here, you can see that this is gonna hit at every single line, and the same thing if I go this way. Right? If I go down, it's going to hit only any possible line. That's what the arrows mean, right? So our answer is going to be all real numbers and all real. Same thing for down here. Right, this is just another line, okay? And then last but not least, this is a quadratic or a parabola. We're going to talk about these much more. If I draw my vertical line to check the domain, and I circle it, right? I'm going to go this way. Do you see how the arrows are going on forever in both directions? So for any U-shaped graph like this, the domain is going to be all reals. Now the range is a different story. So if I look here and I have my line, I'm going to circle this. I'm going to start where the arrows are, and I go down, 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 down. And I can see that eventually I have to stop here because there's no more numbers. So this is going to be -1 all the way to positive infinity because it's going up forever. Okay, so we hope you guys have a great day. Keep working hard, and we will be available via help 8:30 every day, and we're super proud of you guys. Have a great day. Bye.